Good morning, students. In the previous class, we have discussed about Bloch theorem. So, the electron is moving in the periodic potential. So, the solution of the Schrodinger equation is given by Bloch theorem. So, that is, you have studied the solution of the Schrodinger equation xi of x is equal to e to the power e to the power ikx into uk of x. That is the mathematical form of this theorem. So let us use this theorem to understand the formation of bands. First of all, we will consider the nearly free electron theory, in which let us discuss how the energy bands are formed in solids. See, here in this theory, we are considering the electron is moving in the periodic potential. Here, the kinetic energy of the electron is assumed to be always large compared to the periodic potential energy of the crystal. So that is kinetic energy of the electron is large compared to crystal potential. So that means electrons are essentially behaves like free particles. So the weak periodic potential introduced by the positive ions introduces a small amount of perturbation on the motion of electrons. So therefore, we are considering weak perturbating effect on the motion of electrons in this theory. So remember that the positive ion produces a weak effect on the moving electrons. Perturbation produced by the positive ions is so small. That is what we are considering in this theory. So for simplicity, let us consider the one-dimensional Schrodinger's wave equation, that is d square xi by dx square plus 2m by h cut square into e minus v of x of xi of x is equal to 0. This is equation number 1. Okay. So everyone has to note down because it is a very lengthy derivation. Therefore, as I rub it, you have to note down this in your notes. So as I tell the equation number, you have to refer the respective one. So here consider minus in this equation minus 2m by h cut square into v of x is equal to gamma into f of x. Okay. Here f of x is nothing but periodicity of the lattice. It is nothing but periodicity. Okay. Gamma, that introduces the amount of perturbation constant, that one. So now next, this is equation number 2. Now let us take k naught square is equal to 2me by h cut square, or from this equation you can write E is equal to h cut square k naught square divided by 2m. This is equation number 3. Okay. Now you apply the conditions 2 and 3 in equation number 1 and rewrite it, you will get d square xi by dx square plus k naught square plus gamma into f of x to xi of x is equal to 0. That is equation number 4. Now, here we have represented that f of x is represent the periodicity. That means it is a periodic function. So, if the function is periodic, then we can represent that periodic function in terms of Fourier series. So, in the trigonometric form, let us represent this periodic function by the help of a Fourier series f of x. It is the standard form of Fourier series. You have studied this one in electronics in the last semester. F of x is equal to n is equal to minus infinity to plus infinity Cn into e to the power minus 2 pi I nx divided by a, where Cn is the Fourier coefficient. It is nothing but Fourier coefficient. Then a is the lattice constant. It is lattice constant. Now, the Fourier constant is given by Cn is equal to 1 by a integration 0 to a f of x into e to the power 2 pi inx divided by a into dx. So, therefore, this is equation number 5. This is equation number 6. Now, let us apply the same concept for v of x. V of x represent what? It represents the potential of the electron. So, what we have considered? The potential of the electron is also periodic. You have to recall the Bloch theorem. So, v of x is also periodic function. Therefore, let us represent this periodic function again in terms of Fourier series. That means Fourier series can be written as v of x is equal to sigma n is equal to minus infinity to plus infinity some other constant. Here let us represent Vn into e to the power minus 2 pi Ina divided Inx divided by a. Let us substitute the value of v of x in the equation number 2. So, in equation number 2, minus 2m by h cut square. In the place of vx, substitute this. N is equal to minus infinity to plus infinity. Vn e to the power minus 2 pi Inx divided by a. This is equal to gamma into f of x. Gamma into. So, from equation number 5, you substitute the value of f of x. Sigma n is equal to minus infinity to plus infinity Cn into e to the power minus 2 pi Inx divided by a. So, here you simplify this. So, summation sign, you can remove this. That e to the power 2 pi minus 2 pi Inx by a get cancelled. Remaining is what? Minus 2m by h cut square into Vn is equal to gamma into Cn. So, or if you rearrange it, Vn is equal to minus h cut square gamma divided by 2m into Cn. This is equation number 7. Okay. Now, let us recall the Bloch theorem. According to Bloch theorem, wave function xi of x is equal to e to the power ikx into uk of x. So here again uk of x is a periodic function. So what we do? Again, let us represent this one in terms of a Fourier series. Therefore, uk of x is equal to sigma n is equal to minus infinity to plus infinity Fourier constant bn into e to the power minus 2 pi inx by a. This is equation number 8. Therefore, what happens? Wave function xi of x is equal to e to the power ikx into uk of x. Substitute equation number 8 here. Sigma n is equal to minus infinity to plus infinity bn into e to the power minus 2 pi inx divided by a. This is equation number 9. Now, see, as I mentioned earlier, this positive ions produces a small perturbation effect on the electron. That means if you consider the electron which is at center right here, then what happens? The effect of this crystal potential is almost zero. That means what? Electron behaves like a perfectly free particle. That means if the electron behaves like a perfectly free particle, then what happens? The perturbation constant gamma for free particle, it is 0. So, therefore, what happens to the equation? If you consider this gamma is equal to 0, then what happens to the equation? That is wave function for a particle which is perfectly free particle, then xi of x is equal to, I am writing now, this is equal to b naught into e to the power ikx. Yes, it is simpler, right? For any free particle, as you know, we are writing that wave function is in the form xi of x is equal to xi naught into e to the power I into kx minus omega t. So, that is the same thing here also. We are referring t is equal to 0. Then what happens? B naught into, in the place of xi naught, I have taken as b naught. E to the power ikx. This is the equation number 10. Therefore, the total wave function, that means when the electron moves in the crystal potential, at some position it behaves like a perfectly free particle. In some other place, it is perturbed by the small crystal potential. Therefore, total wave function is equal to free particle effect b naught into e to the power ikx plus you have to consider the perturbation effect. So, gamma perturbation factor into Bloch equation ikx into sigma n not equal to 0. For n is equal to 0, we have indicated here. N is equal to 0 means gamma is 0. Bn into e to the power minus 2 pi inx by a. This is equation number 11.